Okay, sometimes we need to find a probability when it's what's called conditional. Okay, and what this means is that one probability is going to affect the other probability. Okay, so I'm going to jump into the definition here and then do some examples, I think. So conditional probability is going to be the probability that event B occurs given that event A has happened. And it's represented as this. The probability of B, and then this little line, this will be new, this little line means given. So the probability of B given A is the way that you would say that. Okay, it's probability of B given A. And I'll show you what I mean by that. So let's do an example. So it says, find the probability that a die rolled shows a 6 given that a flipped coin shows a head. Well, this is probably a bad example to start on, but maybe not. Because, well, this is going to be an independent event, isn't it? So does it matter that, so it says find the probability that a die rolled is a 6, and it says given that a flipped coin shows a head. Does flipping the coin change anything about the die? No, right? Like that doesn't do anything. It's still going to just be a 1 in 6 chance, right? So that was kind of a trick question-ish, where it wants to know whether or not you understand what's a dependent or an independent event, right? So this conditional probability is only going to be when it's a dependent event, right? One depends on the other, or one changes the other. Okay, I'm actually going to move on, I think, to conditional probability formula. Okay, so now another formula. I'm throwing lots of formulas at you guys. So conditional probability formula is if events A and B are not independent events, then the probability of A and B is equal to probability of A times probability of B given A. Okay, and I know, again, that sounds complicated, but remember how it was before? So when they were independent events, it was just the probability of A, I'm going to say intersection B, right, because that is and, was equal to the probability of A times the probability of B, right? That just meant that you just multiply probabilities together, right? So if something is 25% chance, something else is 40% chance, you add those together and that gives you the probability of both of those things happening, okay? So that was before. The only thing that's changing now, so we've still got probability A, but we're going to multiply it by just probability B still, but we just might have to tweak this a little bit because probability A changed probability B, right? This is that example of maybe taking out a card and you have to find the new probability now that you only have 51 cards, right? So it's going to be something like that, right? So again, we got the same picture as before, so it's going to be the area of overlap is what we're doing here. Yeah, but we're just going to have to account for changing B when we do it. So, all right, classic example says, if you pull 2 cards out of a deck, what is the probability that both are spades? So, okay, so 2 cards. That means that you got to pull 1 card out, keep it out, and then pull another card out. So we just have to do these one at a time. So we'll say, okay, what the probability that the first card is a spade is 13 out of 52, right? There's 13 spades in the deck, right? Half the deck is spades. Or sorry, a quarter of the deck is spades. Okay, so that's the first one. That's our spades. And then it says the probability that the second card is a spade, given the first was a spade, right? Or just given that we took a card out of it, right? Well, actually, and it was a spade too, we have to account for because we took a spade out. We'll change up a bit because you can imagine now it was 13 out of 52. Well, now we're missing a spade out of there, right? There's one less spade because we took it out. So how many spades are in there? Well, now there's only 12. And then the bottom, right, the total, there was 52 cards to begin with, and now there's only 51. So that's going to be the probability of the second one, which really just only makes sense, right? After just imagine yourself taking cards away from it, and then you just have to picture what the new probability would be with the missing cards. Okay, and then again, we're going to do the same thing. We multiply probabilities. Probability of A, probability, well, and this is A given B, or sorry, B given A, my bad. Probability of B given A, right? And we should probably have probability. Or probability of A and probability of B given A. All right, and then multiply those, and we end up with, looks like 5.9%. If you change that to a percentage. All right, another one. All right, so now they can get a little trickier, I guess, where they can just add like a little twist on it. So this one says, if you draw 2 cards from a deck, what is the probability that you will get the ace of diamonds and a black card? Okay, so what we actually have to do on this one is we have to split it up into 2 different cases. And the reason for it is because if I'm picking 2 cards, so that's like card 1 and that's card 2 out of my deck, then I could pull out the ace of diamonds first, right? I could pull out like the ace of diamonds. So like, here, let's go ace, and I'll draw like a little diamond. I could pull that one out first, and then pull out a black card, right? Or I could pull out a black card, and then pull out the ace of diamonds. Okay, so either of those things could account or could happen. So if they would have said, if the question would have said, what's the probability of pulling out an ace of diamonds and then pulling out a black card, then all I would do is figure out the like we did in the example above, probability of the ace and then probability of the black card given the ace, right? So just change that up after I pulled the ace out. But this, just the wording of this question is, what's the probability that you will get the ace of diamonds and a black card? So that implies that either of these 2 things could happen. So we have to break this into cases where we'd say, okay, this is case 1 and this is case 2. And then what we do is we find the probability of this happening, the probability of this happening, and then we add cases together. We'll just add those 2 different situations up. Okay? So let's do that. So let's calculate the probability of case A. So probability of case A is you get an ace of diamonds first and then a black card. Okay, so if you think about it, the ace of diamonds, there's only 1 ace of diamonds in the deck. Okay, so the probability of that happening is going to be 1 out of 52. Okay, so that's our first one. So case A is going to be, here, that's case A, or case 1, sorry, case 1. Okay, and then for the next one, the probability that the second card is black, given that the first card is the ace of diamonds, is, okay, well, the ace of diamonds is red. Okay, so we still have all of our black cards left, so we still have 26 black cards in the deck, but I've taken 1 card out of the deck. So now it's over 51, right? It's out of a total of 51 now because it's missing a card. Okay, so then that's going to be 26 out of 51, so that's case 2. Oh, sorry, and my bad. No, we're still on the right track. All right, so then I was wrong here with case 1 and case 2. Sorry, this is all case 1. Sorry if that was confusing. This is still just figuring out the probability of pulling out this first one, right? So probability of ace of diamonds, and then we're multiplying it by the probability of getting a black card. Okay, so this is case 1. So 1 out of 102. Okay. Okay, and then moving on, let's do case 2. So, or sorry, case B or case 2 or whatever. Sorry, I used A's and B's and 1s and 2s. Okay, so now for the other case, the probability that the first card is black is going to be 26 out of 52. Okay, so 26 cards of the 52 total, so a half. The probability that the second card is an ace of diamonds, given that the first card is black, is going to be, well, 1 out of 51, right? There's 1 ace of diamonds, and now there's only 51 cards. So multiply those together, 1 out of 102. So it's the same probability either way, but we do still have to add these probabilities together now, right? And you can think about it this way, that this is probability of A plus probability of B, subtracting the area of overlap, right? But there is really going to be no overlap there, so we're just adding up our cases. If that was confusing, don't worry about it. Just add up your cases when you're done, right? I know there's a lot going on in this question. So then add them all up, and we end up getting 1 over 51. All right, let's do one of these table examples again. So it says a home pregnancy test was given to women, then pregnancy was verified through blood tests. the following table shows the home pregnancy test results. Find, and then it says the probability of not pregnant given the positive test result. Okay, so let's do that one first. So if we're looking at this, the way this works, right, is we've got, okay, so positive test, right? And then here's, pregnant. So if you had a positive test and you ended up pregnant, like actually pregnant with the blood result, then there was 70, right? If you had a positive test, ended up not being pregnant with the blood test, then that was that column, right? And then the total is 75. So 75 would be the amount of positive tests, right? Just adding those up together, right? Okay, and then negative tests, we're gonna have, okay, well 4 would be ones who, this would be women who ended up getting a negative test and then went and got their blood work done and they turned out to be pregnant. Okay, and then our 14 here would be, so this would be negative test, right? So they had like a negative test and then they turned out to actually not be pregnant as well, right? So it was 14 and then a total of 18. Okay, and then your totals are just on this side. So, all right. So it says, since we know the test result was positive, we're limited to the 75 women in the first column. So what that means is that we're saying since we know the test was positive, then it's really just going to be these 75 women for our total, right? So we're not going to look at the women who got a negative test when they did the home pregnancy test. We're only going to look at the positive test, okay? So which ends up being 75. So we know it's going to be something over 75. Now it just says probability not pregnant given positive test result. Okay, so that's just going to be, so not pregnant was just 5. So there's just going to be 5 over 75. So these ones aren't too bad because like with the table, they're actually kind of breaking it up for us. We don't have to do a lot of the work of like, subtracting off the cards like in the last example. This one's just kind of given to us. So it's just probability not being pregnant given the positive test results would just be 5 over 75. Just not pregnant over the total. Okay, that's simple. So since we know the women, for B. So B was the probability of getting positive test result and not being pregnant. Okay, so positive test result and not being pregnant. So now in this case, it's actually just flipped, right? So if we are saying, so positive test result, not pregnant. So since we're limited to knowing, okay, that they're not pregnant, right? So not pregnant, then our total here is going to be 19. So it's going to be something over 19, right? Now, and 5 of those, right? 5 of those had positive test results, or had positive, home pregnancy one, right? So that's really just going to be 5 out of 19. So notice that the wording of these things, these are just flipped around backwards, that they're not the same thing, all right? So play around with those. Like it gets like you have to just kind of get used to using those tables. You guys have a few questions like that in your homework. Yeah, just make sure you practice. All right, and that's it.